This section covers breadboarding, not just breadboards, but also a few electronic components that you'll see throughout the course of this class, as well as any other electronics class you attend. What is a breadboard? Think of it as a proto board or a prototyping board. The one here on the left is a really good example of a breadboard. Uh, Nice to see. It's a nice and small one. You'll see one of these here sometime soon in class. It takes less time and money, way cheaper to do a breadboard than it is to do a pre-printed or fabricated circuit board. It allows designers as well as students to test different components and see how well they work in the circuit, see if they work out for them. If they don't, they can easily pull the component out and throw in a new one. Also allows them to easily modify or change the circuit depending on the different measurements of voltage, current, or resistance. Breadboard works, and if you can see here on the right, by giving you a whole bunch of different internal metal surfaces underneath that when you drop the wires in, everything's connected. So if I look at this breadboard, and on the right side here it shows you everything on this line is connected together, everything on this line is connected together, so you get to see everything and get to connect everything together without having to only have one wire at a time. Use as few jumper wires as possible when you breadboard. You don't want to have a whole bunch of wires bouncing around everywhere. You also don't want to have very long wires going everywhere. It tends to make things a lot harder to track, especially if you run into problems or have a wire break literally right inside the breadboard. As we get to it, you want to make sure that your breadboard is close to the schematic circuit as possible. It makes your life much simpler in trying to figure out what problems there are in troubleshooting. You want to cut component leads to short lengths, but not so short that they won't fit and hold. The longer you cut it, the more fragile they become. A diode, in this case, we're going to call this an LED. It's a light emitting diode. If you look at the picture over here, the shorter lead is a negative. You can also tell, if you can see on the inside, it's a larger piece of metal there. When we look at the schematic symbol, this end of the LED is going to be the negative, this end is going to be positive. So negative is smaller than positive. Looking at the triangle, it follows. Also with the leads of what, the actual metal leads, the shorter one or smaller one is always going to be your negative. Resistors are a way to resist the flow of electricity. We've seen resistance pop up when we've talked about light bulbs as well as wires and a lot of other different components. But resistors are specifically designed to slow the flow of electricity or to lower the flow of electricity or the voltage. A few varieties of different resistors here on the left, and the ones you'll see a lot here in any of your engineering classes, especially at the high school level, are going to be carbon film resistors. These here on the right are potentiometers. We'll use these in class quite a bit next semester. These are a different type of carbon film resistors. These are an older style, ones that aren't used nearly as much. Surface mount resistors are the ones you find on your cell phones and computer circuits. Anything that's very, very small. They slow the flow or lower the flow of electricity through a circuit and do a much better job of it on smaller amounts. To give you an idea, here's a dime and here's a few of the sizes. You will get to see a lot of these carbon film resistors here in class. Most of them are going to be about the size of these two. Color codes are one way that we find out a resistor's value. We can also measure it with a multimeter. You've used these in class and you'll use them again in class. To look at a color code, it gives us what they call the nominal value or the face value. When we use the multimeter, that's an actual value. This is the table that we use that everybody uses to use the color code to find the resistance. You have the first color band, the second color band, our multiplier, which falls in this category here, and we're using SI notation, and then our tolerance, which is just a plus or minus amount. The tolerance being how far above or below the nominal value you can expect the resistor to show when you measure it with a multimeter. Here's an example, and we want to find out the actual the value, the nominal value for this. So I look at the first band, it is brown, so my first digit is going to be brown. The second band is black, so so it's going to be my second digit is going to be 0. So my first and second digit are then 1 and 0. I multiply it by red, so 10 times 100. That gives me 1,000 ohms, but this is not quite in the form we want it. 1,000 ohms is the same as 1 kilo ohms. The tolerance level in this case is the yellow or gold, so that's plus or minus 5%. Another example, first band is orange, so my first digit is 3. Second band is white, so my second digit is 9. Third band is green, so that's 100K. So my number is 39 times 100K, which gives me 3.9 million. When I convert this over to SI notation, it's 3.9 mega ohms. Since my tolerance band still tells me it's 5%, then I add or subtract 5%. Measured value, we've already done this one in class. Won't go into too much more detail with this one at the moment. That's just a quick and general overview of different electrical components that you'll see at the high school level, both in digital electronics, which is the next class after this class, as well as here in POE, as well as how to use a breadboard and how that works out.